Translating a highly abstract concept like Stoic philosophy into a temporally coherent video requires crossing a significant technical divide. When latent video models are prompted directly without structural constraints, the variables shift frame by frame, often resulting in unstable output. Our target for this analysis is a structured, high-retention video with a fixed duration of 3 minutes. This schematic shows the challenge. Reaching our target requires chaining two different AI architectures together, a semantic logic model and a latent rendering model, across this spatial gap. The GenSpark AI workflow functions as the orchestration layer, designed to bridge this multimodal gap. This specific pipeline utilizes two distinct engines. The Claude model handles the logic and text, while Gemini VO executes the latent video synthesis. Successfully chaining these models together depends on executing specific parameter handoffs between the text layer and the video layer. To generate autonomous media reliably, we must treat the AI as a data pipeline that requires specific boundaries to produce predictable results. The architecture begins by feeding the initial thematic prompt into the Claude logic node. The first directive given to the agent is explicit: instruct the model to create a high-retention viral-style script. Immediately, we lock the output requirement to exactly 3 minutes. Without a fixed duration, the script's word count becomes unpredictable. This makes it impossible to align the voiceover timing with the sequence of modular video clips later in the edit. At this stage, the large language model must output its response in two distinct tracks. The audio script data track strictly contains the spoken voiceover. Running alongside it is the technical metadata track, containing visual cues that act as stage directions. Here, the language model operates as a technical director plotting out architectural blueprints, rather than a writer drafting a story. The purpose of this semantic text layer is to pre-calculate the timing and structural metadata required to manage the video layer later in the pipeline. We then move to the translation phase, where the technical metadata track is converted into actionable commands. We instruct the agent to create text-to-video prompts that visually cover the entire story in sequential order. This phase introduces the risk of aesthetic drift. Left to its own devices, a model may gradually alter the visual style of sequential clips, breaking the visual continuity of the video. To prevent this, we hard-code a visual style guide variable. This style guide is systematically appended to every single text-to-video prompt in the entire sequence. As shown here, the bounding box forces the generative model to reference a fixed aesthetic baseline before rendering any new action. This constraint restricts the latent space the AI is allowed to pull data from for each individual clip. Visual consistency is the result of using this persistent style constraint in every rendering request. We now reach the final node, feeding the bounded visual prompts into the Gemini VO video engine. Rigid spatial constraints are manually locked into the generation interface, setting the quality to 1080p and the aspect ratio to 16:9. Standardizing these spatial dimensions ensures the generated assets behave like uniform blocks during final assembly. We also lock the duration of every single clip to exactly 6 seconds. This duration limit is used to mitigate generative hallucination. Generally, the longer an AI generates video without a new prompt, the more likely the physics and logic of the scene are to fail. Setting a 6-second limit stops the generation while the scene's logic is still stable. These stable 6-second modules are then stacked end-to-end. Limiting the AI's temporal window provides a reliable path to generating stable, modular assets for the final edit. Zooming out, we can see the fully assembled multimodal pipeline from start to finish. A single Stoic philosophy idea enters the Claude node and is separated into the audio and metadata tracks. The metadata pulse then acquires the visual style constraint. Finally, the data enters the Gemini VO engine and is extruded into the final 6-second video blocks. The language model handles the structure and timing, while the latent model executes the rendering within a narrow, defined corridor. The efficiency of this GenSpark workflow relies on the application of specific parameter controls at each step. High-fidelity media synthesis is the result of systematically narrowing the AI's generative freedom at each stage of the architecture.